All right, so let's jump into this Spring Boot deep dive.
Okay.
You're here because you want to get practical and understand the code
Yeah.
and see how it all works. So we're going to get into that. We'll tackle some of your burning questions along the way.
Sounds good.
So
Spring Boot's really taken the Java world by storm.
it has.
It's all about making things easier for developers,
Right.
especially when it comes to web applications and microservices.
Okay. And it's known for its batteries included
Mm.
approach.
Yeah.
What does that mean in the context of coding?
Think of it this way. Spring Boot handles a lot of the setup and configuration automatically.
Okay.
So you can really focus on writing the application logic, the
Yeah.
code that makes your app unique,
Yeah.
instead of getting bogged down in all that configuration and boilerplate code.
So less time wrestling with setup, more
Mhm.
time actually building.
Exactly.
That's a win for any developer.
Absolutely.
How does Spring Boot do this? What's happening behind the scenes?
Well, one of the key mechanisms is called auto-configuration. Imagine you add a dependency to your project, let's say Spring Data JPA, to work with your database.
Okay.
Spring Boot will actually automatically detect that dependency
Right.
and configure everything you need to start using JPA.
Wow.
You don't need to manually wire up beans or write a bunch of XML configuration.
So Spring Boot's like a mind reader. It figures out what I want to do based on the libraries I include in my project.
It kind of is. It looks at those dependencies, the properties you've set, and even the environment your application is running in.
Yeah.
Based on all of that, it applies a predefined set of configurations. It's really like having this intelligent assistant that
Yeah.
sets up your development environment.
That's awesome.
Yeah.
And that brings us to starters.
Yeah.
These starter packs that I've heard about that are designed to make things even easier.
Exactly. Starters are essentially packages of dependencies
Okay.
that simplify dependency management. They group related dependencies together.
Okay.
So instead of adding a ton of individual dependencies,
Right.
you add a single starter.
Okay. Can you give me a specific example of how that works?
Sure. Let's say you're building a web application. You'd include the Spring Boot starter web dependency in your project.
Okay.
This starter will pull in everything you need to build that web app. Spring MVC, and embedded Tomcat server libraries for handling JSON.
Right.
And so on one dependency, a whole lot of functionality.
Okay. I'm starting to see the big picture here. We have auto configurations setting things up intelligently.
Yes.
We have these starters bundling dependencies together.
Exactly.
What about the structure of a Spring Boot application? Where does the code actually live?
At the heart of a typical Spring Boot application,
Yeah.
you'll find a main class.
Okay.
This class is annotated with at Spring Boot application.
Right.
And this acts as kind of like a command center.
Okay.
It combines 3 other annotations that enable auto configuration, which kicks off that auto configuration magic we talked about
Right.
at component scan, which tells Spring to scan for components in your application. And at configuration, which lets you define additional configuration beans if you need to.
So this main class is like the entry point to our Spring Boot application.
Yes.
And that at Spring Boot application, annotation sets everything in motion.
You got it.
And within that main class, we have a run method.
Exactly.
This method uses the Spring application class and is responsible for bootstrapping the entire application.
That's right.
So this is all starting to click.
Yeah.
Now, what would a simple practical example of all this look like?
Okay.
Let's say we're building a RESTful web service,
It's okay.
the kind that might power a mobile app.
Sure. To build a RESTful web service, you'd start by creating a controller class.
Okay.
This class handles incoming HTTP requests from clients.
Okay.
And you would annotate this class with @RESTController,
Right.
signaling to Spring Boot that this component is responsible for handling those web requests.
So the controller's like a traffic cop,
Yeah,
directing incoming requests to the right place.
exactly. Within the controller, you define methods to handle different types of requests, like get, post, put, and delete. Okay.
You use annotations like at get mapping, at post mapping, and so on to map those HTTP requests to specific methods.
Okay, that makes sense.
Yeah.
Let's say we want to fetch some data from our application, maybe a list of products. How would we set that up?
You'd create a method within your controller. Let's call it get products.
Okay.
And you annotate that method with at get mapping
Yeah.
products.
Right.
The products part defines the URL path that'll trigger that method.
Okay.
Inside that method, you write the logic to fetch your product data.
So if I make a GET request to products, this method gets called.
Yes.
And then what happens? How do we send that data back to the client?
Right.
And what about formatting it? Like in JSON format.
That's the beauty of Spring Boot. You just return the data from your controller method.
Okay.
Spring Boot handles the rest. It uses a library called Jackson to automatically serialize that data into JSON.
That's really cool. So no need to write any explicit conversion code?
No, you don't.
So far we talked about auto configuration starters,
Yeah.
the basic structure of a Spring Boot application.
And even created a simple REST endpoint.
Right.
What other essential Spring Boot concepts should someone be aware of,
Okay.
especially when it comes to coding?
Well, we can't talk about Spring Boot without mentioning dependency injection.
Okay.
It's a core principle in Spring.
Okay.
And it's all about creating loosely coupled testable code.
Right.
Instead of objects creating their own dependencies, Spring manages and injects them.
So Spring acts as a matchmaker,
Yes.
connecting different parts of our application.
That's a great way to put it. And that leads to more modular and maintainable code.
Okay, and speaking of connecting parts,
Yeah.
what about data access?
Okay.
How do we connect to a database using Spring Boot?
Sure.
Most applications need to work with some kind of database.
Yeah.
How does Spring Boot make that easier?
Right. Well, Spring Boot really excels at data access,
Okay.
especially with relational databases using Spring Data JPA.
Okay.
So this builds upon the Java Persistence API standard, but simplifies things even further.
Okay, so JPA is the underlying technology.
Yes,
And Spring Data JPA adds another layer of convenience on top of it.
you got it. With Spring Data JPA, you define these interfaces called repositories.
Okay.
And these repositories represent your database tables.
Okay.
The really cool part is you don't usually have to write any SQL queries. For basic CRUD operations,
Wow.
read, update, delete Spring Data JPA
Right.
automatically generates those SQL queries
That's amazing.
based on the method names you define in your repository interfaces.
So just by naming the methods in a specific way,
Yes,
Spring Data JPA figures out the SQL query that I need.
exactly. It's pretty powerful.
That sounds almost too good to be true.
I know, right? It is. For example, let's say you have a repository interface for a product entity,
Okay.
and you define a method called findByProductName, string name.
Okay.
Spring Data JPA knows exactly what you mean. It will generate a SQL query
Wow.
that selects products from the database where the product name matches the name you pass in.
So I can write Java code that interacts with the database without having to write any SQL.
That's right, for basic operations.
That's awesome. But what about more complex queries, like if I need to join multiple tables
Right.
or apply some specific filtering logic?
Spring Data JTA has you covered there, too.
Yeah.
You can use the @query annotation
Okay.
to specify your custom SQL statements.
So you have the flexibility to use those auto-generated queries
Yes.
for common scenarios.
Right.
And then I can drop down to custom SQL when I need that fine-grained control.
Exactly. It gives you the best of both worlds.
That's really flexible.
Yeah.
Okay, so we've got data access handled.
Yeah.
What about when things go wrong?
Right.
Errors are a fact of life in software.
Uh-huh.
How does Spring Boot help us with exception handling?
Well, Spring Boot provides a really robust mechanism for handling those exceptions gracefully.
Okay.
You can use the @controller_advice annotation to
Uh-huh.
create what's called a centralized exception handler for your entire application.
Right.
And within that advice class, you
Yeah.
define methods that are annotated with @exceptionHandler. Okay.
To target specific types of exceptions.
So instead of scattering try-catch blocks all over my application,
Yes.
I can create this dedicated place for handling these exceptions.
Precisely. It keeps your code much cleaner and more organized.
Right.
You can log the error. You can return a user-friendly error message back to the client,
Okay.
or even perform other actions needed to recover from that error.
That makes a lot of sense. So we've talked about all the great things about Spring Boot.
Right.
Are there any times when it's not the best choice?
You're right. Spring Boot isn't a one-size-fits-all solution.
Okay.
There are some trade-offs to consider.
Right.
For example, if you're building a really small self-contained application,
Okay.
that doesn't need a lot of external dependencies.
Right.
Using a full-blown framework like Spring Boot might be overkill.
So for tiny projects, the batteries included approach
Yeah,
might be more than I need.
exactly. The framework does introduce some overhead.
In terms of size and startup time, so in those cases, a simpler, more lightweight approach might be better.
Okay, and what about in those situations where I need absolute control
Yes.
over every aspect of my application's configuration?
Right.
Does Spring Boot's magic ever get in the way?
That's a good point. Spring Boot's auto-configuration is powerful.
It is.
But there are times when that level of abstraction can feel limiting.
Okay.
If you need very precise manual control over every detail,
Yeah.
Spring Boot may not be the best fit.
So it's a trade-off.
It is.
The convenience and speed of Spring Boot versus the granular control of a more manual approach.
Precisely. It's all about choosing the right tool for the job.
Right.
But even when Spring Boot isn't the primary framework,
Okay.
you can still leverage its power for specific tasks or modules within a larger application.
So even if I'm not using Spring Boot for the whole project,
Yeah.
I might still use it for certain parts.
Absolutely. For example, Spring Boot's REST capabilities are great. You could integrate a Spring Boot-based REST API
Right.
into an application that's built with something else.
That makes sense.
Mm.
So Spring Boot offers this great way to build modern applications.
Yeah.
But it's important to be aware of the trade-offs
Mm-hmm.
and consider alternative approaches when they make sense.
Right.
But for many developers,
Yeah.
especially those working on web apps, microservices, cloud-native apps,
Yeah.
Spring Boot's a game changer.
I agree. It really simplifies development, speeds up deployments,
Yeah.
integrates seamlessly with other technologies. It's really invaluable in today's fast-paced world.
Speaking of fast-paced,
Yeah.
are there any specific Spring Boot features that really shine
Sure.
when you need to get an application up and running quickly?
Well, one of the key features for rapid development is Spring Boot's embedded servers.
Okay.
You can actually ship your application with a server like Tomcat or Jetty already baked in.
Okay.
No need for separate server installations or complex deployment configurations.
So my Spring Boot application is self-contained.
Yeah.
I can just run it and it has its own web server ready to go.
Exactly. It simplifies development and makes deployment super easy.
Oh, wow. And to make things even smoother, there's Spring Initializer,
Yes.
that web-based tool for quickly scaffolding out those Spring Boot projects.
Right. It's like the easy button for setting up a new application.
It is. You can choose your build tool, like Maven or Gradle.
Mhm.
You can pick your programming language,
Yeah.
select the starter dependencies you need,
Right.
customize some basic settings, and then Spring Initializer just generates a project structure with everything in place. So
Exactly.
you can jump right into writing code.
It's like a project template that's tailored to your needs.
It is, and I've heard it integrates well with popular IDEs too.
It does. You can import that generated project directly into IntelliJ, IDEA, Eclipse, Spring Tool Suite,
Right.
whatever your preferred IDE is.
Yeah.
It really streamlines the setup process.
That's awesome. Okay, so Spring Boot makes it easy to get started.
Yeah.
Get our application running, connect to a database.
Uh-huh.
What about working with APIs?
Okay.
A lot of modern applications rely heavily on interacting with external APIs.
They do.
How does Spring Boot handle that?
Spring Boot has excellent support for building and consuming RESTful APIs.
Okay.
For building APIs, as we talked about earlier,
Right.
you use controllers with annotations like at REST controller, at get mapping, at post mapping, and so on.
Okay.
And Spring takes care of mapping those HTTP requests to your methods,
Right.
handling the data serialization, all that good stuff.
Right. We saw a bit of that when we created that simple REST endpoint.
Yeah.
But what about consuming external APIs?
Okay.
Let's say my application needs to fetch data from a weather API.
Right.
Or process payments through a payment gateway API.
Spring's REST template is a really popular choice
Okay.
for interacting with those RESTful APIs.
Right.
It provides the simple, synchronous way to make HTTP requests and handle responses.
Okay.
You can use it to send get, post, put, delete requests,
Right.
set headers, handle different content types, all of that.
Can you walk me through a simple example of how I might use REST templates
Sure.
to interact with an external API?
Yeah. Let's say you want to fetch the current weather conditions from a weather API.
Okay.
You'd first create an instance of REST template,
Okay.
and then you use its get for object method,
All right.
passing in the API endpoint URL and the expected response type.
Right.
Spring handles making that HTTP GET request,
Right.
receiving the JSON response, and deserializing it into a Java object that you can work with.
That sounds pretty straightforward.
Yeah.
Are there any best practices or gotchas to be aware of when using REST template?
One thing to keep in mind is that REST template is a synchronous client.
Okay.
This means your application will block while it's waiting for that API response.
Right.
If you're making a lot of API calls,
Yeah.
especially long-running ones,
Right.
it could impact the performance of your application.
So if I'm dealing with a lot of API calls
Yeah.
or calls that might take some time,
Yeah.
what are my options?
For those more advanced scenarios, you might consider using an asynchronous HTTP client,
Yeah.
like Spring's web client.
Right.
It lets you make those non-blocking requests.
Okay.
So your app can continue doing other work while it's waiting for those responses.
Yeah.
This can really improve the performance and responsiveness of your application.
Interesting. So synchronous calls with REST template for simple cases.
Yeah,
Asynchronous calls with web client when performance is really critical.
exactly.
Are there any other considerations when working with APIs, especially in the context of Spring Boot?
Well, security is super important.
Right.
Whenever you're interacting with external APIs,
Yeah.
you need to make sure you're doing so securely.
Right.
This might involve using API keys,
Yeah.
authentication tokens, or other security mechanisms provided by the API.
Okay.
Spring Security is a powerful framework for securing Spring applications,
Right.
and it can be integrated with Spring Boot to
Okay.
handle that API authentication authorization.
Security is definitely crucial. And I imagine error handling is also important when dealing with those external APIs.
Absolutely. You need to be prepared for things to go wrong.
Right.
This might involve gracefully handling exceptions,
Great.
implementing retry mechanisms, or providing fallback options
Right.
in case that API is unavailable.
Makes sense.
Spring Boot's exception handling mechanisms, along with its support for aspects and interceptors,
Okay.
really give you the tools you need to implement a solid error handling strategy.
This has been a really insightful deep dive into Spring Boot.
It had.
We've covered a lot of ground, the core principles,
Yeah.
practical examples, working with databases,
Uh-huh.
building and consuming APIs, even considering alternatives and trade-offs.
Yes.
As we wrap up, any final thoughts for our listener who's eager to dive into the world of Spring Boot?
I would say Spring Boot offers a fantastic way to build robust modern applications.
Okay.
It really streamlines that development process. It empowers you to focus on the core logic of your application.
Okay.
And it provides a rich ecosystem of tools and libraries to tackle a wide range of challenges.
Got that.
So embrace that convention over configuration philosophy.
Right.
Leverage the power of auto-configuration.
Right.
And don't hesitate to explore all the vast resources that are
Sure.
available in the Spring Boot community.
Great advice. And I think one of the key takeaways here is that Spring Boot is all about making developers' lives easier.
Absolutely.
It takes care of all the boilerplate provides sensible defaults
Yeah,
and lets us really focus on writing the code that matters.
that's right.
So to our listener, dive in, experiment, and start building something amazing with Spring Boot.
I agree.